Hello everyone, welcome to the sixth lecture of the series on AI using Python. In this lecture, we will discuss about logistic regression and its illustration using examples in Python. In logistic regression, the output data can take a value between 0 and 1 and it normally characterizes the probability. We normally use logistic regression to find the probability of the input to be in a particular category. And it is used to find a model that can answer an yes or no type problem or a binary classification problem. Therefore, even though logistic regression is named under the group of regression, it is normally used for solving classification problems. And in logistic regression, we use the logistic function for modeling probabilities. And the logistic function, which we can also call as the sigmoid function, is defined as in this equation, where e raised to x is the exponential function. So here, if we multiply the numerator and denominator with the e raised to minus x, we get this expression. Here we can see that as x tends to infinity, e raised to minus x will tends to 0. So 1 by 1 plus e raised to minus x will tends to 1. And similarly, as x tends to minus infinity, e raised to minus x will tends to plus infinity. And this will make 1 by 1 plus e raised to minus x tends to 0. In the logistic regression, the training data consists of n observations of inputs such as x1, x2 up to xn and n observations of outputs such as y1, y2, yn. And in the case of logistic regression, the outputs or labels will be usually in the form of zeros and ones. But it can also take continuous values in between 0 and 1. Now we can choose the model in the case of logistic regression as in this equation, where we introduce some free parameters which are a and b, and the model becomes 1 by 1 plus e raised to minus ax plus b, which is also equal to logistic of ax plus b. Then our objective is to find the best values of a and b that fits this input output data. Next, we can visualize the logistic function in Python. And for that, first we can import the libraries. So here we'll be using the NumPy and Matplotlib libraries. And we define the input as 100 equally spaced data points between minus 10 and 10, for which the output is defined as 1 by 1 plus e raised to minus 3x plus 2. So here a is chosen as 3 and b is chosen as 2. Then we plot x versus y, and we can see that the plot will looks like this. Now here if we change this value of a and b, we can see that the plot will also changes its shape. For example, if we change the value of a as 0.5 and run it, we get the plot like this. And let's say if we change this to minus 0.5, we can see that the plot will looks like this. And we can observe that for whatever values of a and b, the value of the output will be between 1 and 0. So this basically means this output can be considered as some probability. And normally in the case of classification problem, if the output of this function is greater than 0.5, we will consider it as 1. And if the output is less than 0.5, we consider it as 0. Next, we consider an example for illustrating logistic regression, and in which we select the training input xtr as 10 equally spaced data points between minus 10 and 10, and this we rearrange in the form of a column array. And the ytr is defined as an array containing 10 elements, where we select the first 7 elements as 0 and the rest 3 as 1. And similarly, the text input xts is selected as 20 equally spaced points between minus 10 and 10. And in this example, we will be using the logistic regression function from the sklearn library for computing the model. Then we can use the logistic regression function for learning a model, in which we set the maximum number of iteration as 500 and the solver is set as LBFGS, which stands for limited memory BFGS algorithm, which is a numerical optimization algorithm. Then we can train the logistic regression model using the training data, which is XTR and YTR, and which will basically fits a logistic function to this given data. And the trained model we denote as model underscore LO. When we run this part, this model will be trained, and we can find the a and b, so which are the free parameters in the model, using the model name dot coefficient and model name dot intercept command, which gives a as 0.93 and B as minus 4.15. Now, using this value of A and B, we can construct a logistic function and predict the value of the output using this logistic function. And this value we denote as YLM, which will be equal to 1 by 1 plus e raised to minus A x plus B. So here we use the testing data instead of x. And similarly, we can also use the predict function in the logistic regression, and the predicted output we denote as y underscore LO. If we use this predict function, it will predict the value of output as either 0 or 1. However, in this case, this will be like a continuous curve, which is basically the plot of the logistic function. Then we can plot xtr versus ytr and xtss versus y underscore lm and xtss versus y underscore lo. And we can see that red dots will be corresponding to the training data. And this black curve will be the logistic function, which takes a value between 0 and 1. And this green curve will be corresponding to the predicted output for the testing data. Basically, if this logistic function output is greater than 0.5, we give the predicted output as 1. And if it is less than 0.5, we set the predicted output as 0. So this we can also observe from here. With that, we comes to the end of this lecture. Thank you.